Example 1, draw a 147-degree angle in standard position. Mark the reference angle and find its measure. Then find cosine of 147 degrees and cosine of the theta reference or the reference angle. Explain the relationship between the two cosine values. So we have our requirement. And our requirements are to find the cosine of that certain angle 147 degrees. So in essence, 147 degrees is in between your 0 degrees and 180 degrees. So it's somewhere here. Okay, now our ray is this. So from the origin going here, that's our ray. So this would be our ray. What is our reference angle? This is our reference angle. So theta ref. And this is our theta. So what is our theta? Our theta is 147 degrees. So make sure you write degrees with your 47. So cosine of 147 degrees. So if our theta is 147 degrees, what is our reference angle? Since it's the positive acute angle, so our theta ref is equal to 180 degrees minus 147 degrees, and this is equal to 33 degrees. So theta ref is 33 degrees. Now we will evaluate our cosine of 147 degrees. And we have to evaluate this cosine of a certain degree using a calculator. So grab your calculator and press cosine of 147. In the calculator, if your calculator is in the mode of degree and not radian, then cosine of 147 without degree will give you the cosine of 147 degrees. So that is negative 0.8386, like that. Okay? Then what about comparing it to our angle of reference or reference angle? So cosine of 33 degrees would give us how much? Cosine of 33 will give us 0 point. So they are of the same magnitude. They have the same magnitude but different in sign. So what is the relationship of our cosine of 147 degrees and our cosine of 33 degrees? First of all, where is our theta? Our theta is in quadrant 2, right? This is our rotating ray, and the rotating ray took us to 147 degrees, which is here. And in this theta, our terminal side is here, and 147 degrees is in quadrant 2. Am I correct? And in quadrant 2, your cosine will be negative and your sine would be positive. So solving for our cosine 147 degrees gives us a negative value, which is cosine of which is a negative cosine. Okay, so we will have a negative value for cosine 147 degrees. Whereas when we take the cosine of our reference angle, since our reference angle is 33 degrees and it's always a positive acute angle, then getting our cosine of 33 degrees will always give us positive value. Why? Why is it like that? Why is it like that? Because it's always a positive value for the angle, meaning that it's an acute angle and it's always positive. So meaning whatever you get from there, for example, we have it's an acute angle. So meaning these acute angles are within the range of 0 and 90 degrees. Okay, it's within 0, in between 0 and 90 degrees. So because these are acute angles, they will always give us a positive value for either sine or cosine. Okay? So meaning that for reference angles, all the answers would be positive. And this is for example number 1. Example number 2. The terminal side of angle theta in standard position contains the point UV is equal to 8 negative 5. Sketch the angle in standard position and use the definitions of sine and cosine to find sine theta and cosine theta. So we are given a point here and the terminal side containing that point UV. So our terminal side appears to be in quadrant 4 because what is the point? It's 8 negative 5. So in essence 8 negative 5 is in quadrant 4. So it would be here to here. Okay, that's where our point is. So my point here is in quadrant 4. And what is this UV point? 8 negative 5. Okay? Now you could plot this 8 negative 5 on a standard XY axis or a UV axis. Anyway, U could stand for X and V could stand for your Y in case you are still confused on how to use them. So after this, the terminal side of angle theta is in quadrant 4, meaning that it has rotated from here to this point. This is our theta. And this is our reference angle, just to write down. This is our theta ref. Okay? And of course, we would like to get this is our V, and the length of this V is 5. So the distance from this up to this is 5. Okay, so V is actually equal to 5, and U is equal to 8. Right? And we have definitely a right angle here defined. Okay? And then so what is our hypotenuse? We have to look for our hypotenuse. And where is our hypotenuse? This is our hypotenuse R. So what is R? So because this is a right triangle, this is a right triangle, so meaning we can use the Pythagorean theorem. So use the Pythagorean theorem for right triangles. And what is the Pythagorean theorem? The Pythagorean theorem states that if you have a right angle, then the squares of the two sides is equal to the square of the longest side, or the hypotenuse. So a squared plus b squared is equal to c squared. This is the standard theorem. But in here, we are going to translate the following, or substitute the following variables for the corresponding variables here. So our a here is u, let's say. Okay, so u squared plus v square is equal to r square. And our u is 8, so it's 8 square plus, so 8 square plus 5 square is equal to r square. And r square is equal to 64 plus 25. So our r is therefore the square root of 89. And because r is always positive, okay, r is always positive because actually r is the radius of your circle. We have a circle here, and r is always the radius of the circle. So r is always positive. Okay, so because we have our r now, then the definition of our sine theta, our sine of theta is equal to sine of 147 degrees. I'm sorry, we don't have our theta. So this is equal to v over r in the definition. So our v is 5 and our r is square root of 89. Correct? And using a calculator to solve for the value of our sine theta here, we have 5 divided by square root of 89, and that will give us 0. This is equal to 0.5299. Okay? Now for the value of cosine, so this is for our sine, and for our cosine, so cosine of theta is just equal to v or u over r. And our u here is 8. So we have 8 over square root of 89. That will give us a value which is equal to 8 divided by 89, or square root of 89. So that will be 0.8479. Okay, these are the values of our sine theta and cosine theta. But are we finished? No, we didn't. We did not yet include the quadrant in which these values belong. So you can see that, we are on the fourth quadrant. And on the fourth quadrant, we have positive for cosine and negative for sine. Therefore, this one would be negative. This would be negative because our sine of the theta is negative, but this one is positive. Okay? So the value of this is negative, and this is positive. Okay? So these are the answers for this example. Okay.